Hey guys, we are looking at number 1, which is, this is 7.1. So this is going to seem kind of odd because this is the only section of chapter 7. So we're in 7.1 today and then 8.1 tomorrow. So this is really just kind of a review of matrices. So this is matrices, and we'll make sure it's one section, and that's it. A lot of what we're going to do you should have already seen before, but probably need a refresh, and maybe some stuff is brand new. So we'll look at it. We're going to start off. It says solve each system of linear equations. Well, you learned how to do this way back in Algebra 1. That's where you use your substitution, elimination, or graphing. Well, we're going to introduce another way, and that's with matrices. We're going to solve this system of equations. Matrices. Now I'm going to start off by giving you the answer. So there's the answer to that system of equations. Okay. And so I'm giving you the answer to show, well, how do I find that answer using my calculator? So I'm going to pull my calculator up, move it over here on the side and over here. Pull my add page. Now I need to turn this into a matrix. Specifically, I'm going to turn it into a 2 by 3 matrix, because there's 2 rows here and then 3 different columns. My first column is going to be my X column. The second column is the Y column. And then the last column, I call it the equals. It's whatever number's on the end. My rows are by equation. So for instance, this right here, that first equation is going to be my first row. So the X value in the first row is 2. So I'm going to put a 2 there. The Y value is 5. And the equals is negative 25. Well, my second row is going to be my second equation. The X value in the second equation is 4. I see negative Y, so that's negative 1. And then 5. Now, if I was missing a variable altogether, let's say I didn't have an X at all in that bottom equation, I would put a 0 in for X in the bottom equation. So that's how I come up with my matrix that matches that system of equations. Well, how do I do that in my calculator? Well, you notice in blue right here, the calculator has a matrix button. So I'll hit this button right here. So second, and then X to the negative 1. And then this pops up on my screen. I'm going to go over to edit. So I'm going to click over to edit and hit enter. And it says matrix A. And then instead of 1 by 1, it defaults to 1 by 1. I want to change those dimensions because mine's a 2 by 3. So 2, enter, 3, enter. And now it gives me little zeros that are in the same form as my matrix. So I'm also typing my numbers. 2, enter. 5, enter. 25, enter. And I hit enter each time. 4, enter. Negative 1, enter. 5, and then make sure you hit enter one last time. Now this next step is really important, though it seems kind of useless. I'm going to hit the second button and then mode or quit. All right, I'll just go back to the main screen. And then I'm going to hit second matrix again. It's really important that I hit second quit and go back here before I do anything else. Otherwise, it tries to put stuff in my matrix where I left off. So now I can hit second matrix. Okay. I see that now under names, A says 2 by 3. It's because there's the matrix that I just made. All right, we're going to come back to that in a second. Before I do, I'm going to go over to math, and I am looking for REF. So if I do my pages to show you this one right there. That's the one I want, REF. Okay, so I click on REF. It stands for reduced row echelon form, parentheses. Well, it's saying, well, what do you want me to find the reduced row echelon form of? It's wanting a matrix. Well, I'm going to go hit second matrix. Come down here now, I'm under names. I want matrix A. So hit enter. And it puts matrix A right there. Parentheses, hit enter. And this is the matrix it gives me. Well, now this is really important. The first two, or the first little box, should always look like that. It should be a diagonal of ones. Everything else is zeros. Okay? Well, remember that this one right here, this was the x. That one right there was the x. And I get 1x is 0. Well, x is 0. So over here on my answer, x is 0. Well, if I see right here, that 1 right there, that 1 is in the y spot. And it's telling me that y is -5. So over here on my answer, I see y is -5. So that last column is the answer. It's not coordinate point. Okay. I'm going to skip over the next one. You can try this one yourself. 5, 3 is what you should get. So try this one on a calculator. 5, 3. Let's look at number 3. Number 3 is another system of equations, but this is a 3-variable system of equations. All right? So my calculator doesn't really care how many variables there are, how many equations there are. It can do it all. Okay, I can do 4 or 5 variable equations. So let's do it again. Let's figure out what my matrix is going to look like. So I have 3 different equations. So I'm going to have a 3 by, and then really, if I look, I have x, y, z, and then an equal to number. So this is 3 by 4. That second number is always 1 more than the first one. So I have a 3 by 4. Well, again, my first row gives me my first column. We're going to have x, y, z, and then our equal to. Okay. Well, notice my first equation does not have an x. So I'll start off by just putting 0 because it's missing the x. My y value is -2. My z is -5. My equals is 10. All right. My x value for the next one is -3. The y is 4. The z is -3. And the equal to is 18. -2, 2, 1, 6. Right? So there's the equation that I'm supposed to get. I want to type it into my calculator, so I'm going to go to second matrix, go over to edit. I'm going to come down to, I need to change A to be 3, enter, 4, enter. I'm going to go ahead and tell you that when you're doing matrices like this, it's really easy to make a mistake. So I'm going to purposely make a mistake here, and maybe accidentally make one too, who knows. I'm going to purposely make a mistake just so you can see what the calculator is going to look like after if you make a mistake, and that way you can spot those, all right? So I'm going to type these in and see if you can spot where I make a mistake. All right, there we go. I'm done. So let's type them in. I need to hit second, quit. And because I use matrix A again, I can just go up and highlight reduce row echelon A, hit enter, and get my answer. That looks really weird. Maybe highlight didn't work. So let's see. Just to remind you how I do that. If I didn't have it up there, I went over second matrix, go over to math, double REF, second matrix, enter. Same thing. Okay. Notice I still get my diagonal of ones. That's good. I want a diagonal of ones. What I don't want is decimals over here. Now, these doesn't mean that I can never get decimal answers in general, but for the problems that I'm giving you, you should always have whole number answers. If you get decimals like I just did, it means you made a mistake typing your matrix in, which is, again, very easy to do. So I'm going to hit, the easiest way to find it is hit math, second matrix, not math, second matrix. And then instead of going over to math, just hit enter on A. So it says just matrix A, hit enter, and it pops up the matrix that I plugged in. And this is the easiest way of seeing the matrix and then seeing what mistakes I made. So I'm going to look and say, okay, well, what did I type in here that's different than what I was supposed to have typed in? Well, if I look at the top, 0, -2, -5, 10, that's fine. And then I'm supposed to have -3, and oh, nope, there it is right there. So that 3 right there is supposed to be negative, and I made it positive. Let's keep looking. 4, -3, 18. Okay, that's good. -2, 2, 1, 6. The rest of that's good. I just need to go back and fix that -3. So, second matrix. Let's go over to edit. Hit enter. And I need to come down to that 3 and change it to a -3. Enter. All right, now I'll hit second quit. Now I can come up to that double REF, hit enter, and I now get -4, 0, -2. Well, let's look and see what the answers were supposed to be. Look there, -4, 0, -2. Now, this is 3 different numbers. This is still a coordinate point. This is a 3-dimensional coordinate point. It has an x-axis, which goes side to side, a y-axis, which goes up and down, and then a z-axis, which goes like towards you off your paper and then away from you. So it's a 3-dimensional coordinate. I'll show you the answer to number 4. So that's the answer you should get. If you try number 4 here on your own, that's the answer you should get. All right. Now my calculator can do a lot of different matrix operations for me. However, it can only do it if my matrices only have numbers in it. So notice number 5 has letters, so I cannot do this one on my calculator. I'm going to have to do this one by hand. So I'm going to start my video. And a little side light on. There we go. And we'll work out number 5. All right. So number 5, I have -5y, 2yx minus 5, x, yx, -3y. -3 plus x, -5y, x, y squared. Okay. So first thing I need to do is distribute my -5y. So distribute it through the first one. I do this because this is not in parentheses. If I had parentheses around my 2 brackets and the -5 outside of them, I would subtract these first. But because my -5y is being multiplied with this one, but not that one, I have to distribute it first before I can subtract. Just following the normal order of operations. I just multiply it by all my terms inside. So let's see here. -5 times 2 is -10. Y times y is y squared. And then I have an x. I need to distribute by the second term as well, so that becomes positive 25y. Do my next term, -5y, and then x. Here I have -5y squared, x. And then lastly, I get positive 15y y squared. Bracket minus -3 plus x, -5y. I'm sorry, I should turn screen share off, that way you can see that a little bigger. -5y, all right, x, and then y squared. There we go. So because I didn't have full screen on, so I distributed that to each one of those, and that gives me this right here. Okay, this I just brought down just the way it is, and I'm going to subtract. Now remember, when I subtract, I'm distributing that negative to these and combining like terms. If there's any like terms I can combine. Well, let's look at these first ones. I have y squared x, y, a constant, and an x. None of those are like terms. So I'm just going to list my terms out. I have -10 y squared x plus 25y, and then just distribute my negative. Plus 3 minus x. There's my first term. I know it doesn't look pretty, but there's nothing there I can combine. That's about as far as I'm going to go with that. So my next one, I have -5yx and then 5y. Not like terms, so I'm just going to list them out. -5yx, distribute my negative, and that becomes positive 5y. The next one, -5y squared x, just an x. Can't combine those two, so -5y squared x, distribute the negative, minus x. Lastly, 15y squared, y squared. Oh, both y squared, I can combine those two. So 15 minus +1 is 14y squared. And that is my answer. So now I'll go back to share screen. There's the answer. Again, they might rearrange terms a little bit, and actually, no, they left terms exactly the same order I did. All right, and that's what we got. So I'm going to click through and just show answers. I'm just going to do one of each type. This is the answer you should get for number 6. You can distribute the 5p and then subtract. For this one, you can technically do this on your calculator, but it's way easier to do it by hand. Notice there's parentheses, so I'm going to wait and add those together first before I multiply by 2. So add the individual numbers together and then multiply by 2. 1 plus 3 is 4. And you multiply by 2, you get 8. And then this one right here. Subtract those two together and then add to that one. You should get 0, -2, -1, 3, -3, 11. Try those. Make sure you do effective those answers. All right, and then we move on to matrix multiplication. I'm going to switch to one. Now let's do both. Okay, so I'm going to write them both out on my paper. And then I'm going to move my screen off so you can see the paper full screen. So number 9, -1, -4, 0, 6, -3. And then number 10, -6, 6, -6, 2, -2, 6, 2, 0, -2, 4. All right. Down. Look at number 9. So we're multiplying. When I'm multiplying, my first matrix is my row matrix. Second matrix is my column. Okay. With matrices, order does matter. So normally with multiplication, 2 times 3 is the same thing as 3 times 2. Okay, order doesn't matter. But with matrices, order actually does matter. So these two, would not be the same as if I reversed them. So first matrix is row, second matrix is column. Underneath the matrices, I want to write down what the dimensions are. You know, my dimensions are height by width. So this one has a height of 3, or 3 different rows, by only a width of 1, or 1 column. This one has a height of 1 and a width of 2 columns. Okay? Now, for matrices, some multiplication problems I cannot actually do. They're undefined. I can figure out whether I can multiply these two matrices together by whether or not those two numbers, the inside numbers, match. Well, 1 and 1 are the same, so yes, I can multiply these. Well, what is my answer going to look like? My answer is going to be a matrix, and it's specifically going to be a 3 by 2 matrix. The outside numbers give me my dimensions. So I'm going to draw a 3 column, 2 row matrix. Then we'll put lines just to help me see what this is. 3 rows, 2 columns. Okay. Well, where do I get my numbers that go in here? How do I actually multiply? So I'm going to pick a box, and it doesn't really matter which box. So I'll start with this one right here, this first box. This box is in the first row of my answer. So I'm going to look at the first row of my row matrix, okay? This box is in the first column, so I'm going to look at the first column in my column matrix. Now, these only have 1 number in them. Sometimes I'll have more than one, that's okay. I'm going to multiply those numbers together. -1 times 6 is -6. Let's pick a different one. How about this one? This box is in the still the first row, but it's in the second column. -1, -3, +3. Look at this box. Now we're in the second row, first column, -4 times 6, -24. This box right here is in the second row, second column. So -4, -3 make 12. Lastly, these two numbers are in the third row. Well, notice that my third row is a 0. Well, so I'll have 0 times 6 and 0 times -3, both of which will give me 0. So this would be my answer. Well, let's look at one where it's not just individual numbers or single numbers. Let's look at number 10. Number 10, this one is a 3 by 2. This one is a 2 by 2. Can I multiply these together? Well, my middle numbers are the same, so yes. What's my answer going to be? My answer is going to be a 3 by 2. Okay, another 3 by 2. So make another 3 by 2. All right, well, I'll start with this box right here. This is my 3 by 2. You couldn't see it because it was all the way on the screen. This is a 3 by 2 matrix. I made 3 by 2, the outside numbers. This box right here is in the first row, so I'm going to circle the first row. Notice there's multiple numbers there, specifically 2. Well, this box is also in the first column, so I'm going to circle the first column. And I just realized I forgot. Right, row. Well, I told you the very first thing you're supposed to do is row, column. There's my row, there's my column. Now I have 2 different numbers multiplied in each, okay? So what I'm going to do is I'm going to say, well, the first number here is -6. The first number here is 2. I'm going to multiply those 2 numbers together. -6 times 2 is -12. Kind of wrote it small there. And then I'm going to say plus, now my next numbers, 6 times negative 2. 6 times negative 2 is also negative 12. Okay? So when I have multiple numbers, I just multiply them individually and then add them together. And then I get negative 12 plus negative 12 is negative 24. There's my value. All right, let's do another box. How about this one right here? This one's still in the first row, but now it's in the second column. Negative 6 times 0 is 0, plus 6 times 4, 24. 0 plus 24 is 24. All right, moving on to our second row. So I'm going to circle the second row. Well, let's do this box. So this is in the first column right here. Negative 6 times 2 is negative 12. 2 times negative 2 is negative 4. And of course, I putting plus right here. If you want to say, oh, well, this number is negative, so it's really negative 12 minus 12, negative 12 minus 4. That's perfectly fine. Okay. And then over here, negative 6 times 0, 2 times 4. Negative 12 plus negative 4 is negative 16. 0 plus 4 is 4. Last row. Negative 2 times, oh, sorry, I'm in my third row. This box is in the first column. So first row, third row, first column. Negative 2 times 2 is negative 4. 6 times negative 2 is negative 12. And together, negative 16. This last box, third row, second column. Negative 2 times 0, 0. 6 times 4, 24. The value's 24. Now, I'm going to write that a little bit cleaner. I'm going to say I have negative 24, 24, negative 16, 4, negative 16, 24. And that would be my final answer. All right. Now, you can do those on your calculator. The problem is you're eventually going to have to do one like number 11 that you cannot do on your calculator. So that's why I showed you how to do them by hand. Okay. Number 11 is the same way, it just has numbers mixed in with it too. So go ahead and try that one, and that's what you should get. Okay. The letters are put there just so you have to do this one by hand. You can't just play it in the calculator. Determinants. All right. For determinants, this is number 12. You can do this on your calculator, but it is one like number 12 is so easy, it's way quicker just to do it by hand. All right. First, I'm going to show you the little formula for it. A, B, C, D. Okay. What you do is you take your first diagonal, start in the top left corner. Your first diagonal is A times D. Okay. So multiply that first diagonal. And then you say minus, I multiply my second diagonal. C times B. Okay. And that's all I'm determinant. Well, let's look at number 12. Number 12 is negative 2, 3, 5, 4. Okay. So let's equal to full screen. The first diagonal, A times B, minus the second diagonal, C times B. All right, for ours, my first diagonal is negative 2 times 4. Minus my second diagonal, which is 5 times 3. Well, negative 2 times 4 is negative 8. 5 times 3 is 15. 8. Negative 8 minus 15 is negative 23. My answer, there you go, negative 23. All there is to that. All right. If you want to try number 13, you should get negative 6. Well, what about if they have 3, or if there's a 3 by 3 matrix? Well, those by hand is very tedious, so we're going to do them this way. Okay. Here's the second matrix. Then go over to edit. Enter. This is a 3 by 3 matrix, so I'm going to type 3, enter, 3, enter. I'm going to type my values out. 2, negative 1, negative 1, 3, negative 4, negative 1, 2, negative 5, 5. Okay, so there's my numbers. Second quit. Every time I type in a matrix, I always hit second quit. Then second matrix. Go over to math, and the very first thing on the list says DET for determinant. So hit enter, and say second matrix. I want to find the determinant of A. So it says the determinant of A is negative 29. If I come over here, the determinant is negative 29. You could do that same thing on the previous ones, the 2 by 2s. I think it's just quicker to do them by hand, but if you want to, you can do that. All right. Next thing we're going to look at is inverses. All right. I'm going to write down a column number 16. I get negative 2, negative 4, negative 10, negative 8. So let's start the video, share so you can see the problem. Sorry, I'll put this down a little bit on me. All right, so in general, my formula is if I have A, B, C, D. All right, so there's my function I have. My inverse is 1 over DET, meaning the reciprocal of the determinant. Parentheses. I'm going to take my first diagonal and just flip them. So I'm going to move this number here, up here, D. Move A down here. For C and B, I'm going to leave them where they are, but I'm going to change the signs. So negative C, negative B. Okay, that's my formula for an inverse. Well, what does that look like? Well, I need to find the determinant. My determinant is my first diagonal multiplied together, that's 16, minus my second diagonal, that would be 40. 16 minus 40 is 24, negative 24. So my determinant is negative 24, so my inverse is going to be 1 over the determinant, negative 24. Switch my first diagonal, so negative 8 comes up here, negative 2 goes there. And then I change the sign of my next answer. This one's negative, so it becomes positive. This one's also negative, so it also becomes positive. And that is my inverse. There's the answer. Here's what we just came up with. Here's another one to try. 17 is this. Now, as you're doing this, you may end up with one where your determinant is 0. Okay? Your determinant is 0. Well, notice if you get a determinant of 0 and you put 1 over 0, you have 0 in the denominator, which you can have. So if you're ever doing this, an inverse, and you find that the determinant is 0, you just stop and say no inverse exists. Okay? No inverse exists if the determinant is 0. another one. Oh, there you go. See this one, if I do 8 times 0, I get 0. 3 times 0, I get 0. Subtract, I get 0. So here, no inverse exists because the determinant would be 0. All right. Now, it says if there is no unique solution. We're trying to figure out what matrix would go in for y. So I'm going to write out my problem. Six, 2, negative 18, 20. So I need to figure out, well, what is going to go in for y? Well, this one's actually pretty easy. All I need to do is divide both sides by negative 2. If I divide both sides by negative 2, I get 6 divided by negative 2 is negative 3. Negative 2 divided by negative 2 is negative 1. Negative 18 divided by negative 2 is positive 9. And then that gives me 10. And that has to be y. So if it's just a matrix times we call it a scalar or a constant, then it's fine. Simple enough. But what if I get a problem that looks like this one? Well, I can't really just divide a matrix by another matrix. At least I don't know how to. I'm not saying you just can't. I don't know how to. So maybe you can't, maybe you can't. But I'm going to write out this problem, and we're going to see how we can do this. 5, negative 10, 8, negative 16, 1, negative 2, 4, negative 2, C. Now, I know that C is a matrix. So I'm going to replace C with a matrix A, B, C, D. Okay? I'm going to put a matrix here on top of C. I'm replacing C with this kind of matrix. So I know it's a matrix. And I guess I jumped ahead a little bit. I should have said that this matrix right here is a 2 by 2. This matrix here is also a 2 by 2. And then I should have asked you what are the dimensions of C? Well, I know that it can multiply so that this number and the first number here have to match. So this number is a 2. So this number has to be a 2. So they have to match. And then my outside numbers make the answer. Well, this is 2 by 2. There's the first 2. This number right here has to be a 2. So that's how I got that dimension. Explain that out before I just wrote it down. Okay. Now I'm actually going to multiply these two matrices together. Okay. I know it makes a 2 by 2 matrix. Okay. Well, let's multiply. First row, first column. 1 times A is 1A. Negative 2 times C minus 2C. Oh, this one. First row, second column. 1B minus 2D. Now here's second row, first column. 4A minus 2C. Second row, second column. 4B minus 2D. Now, well, I know that after I multiply these together, I get this. So this number 5 right here has to equal that right there. So these two have to equal each other, meaning that 1A minus 2c has to equal 5. And notice that this one has an a and a c in it. This one also has an a and a c. So over here, I know that 4a minus 2c has to equal negative 10. Over here on the other side, I'm going to do the same thing with these. This one right here has to equal 8. 1b minus 2d equals 8. Also, 4b minus 2d, this one right here, has to equal negative 16. Okay. Well, notice I now have a system of equations. Right? I have two equations, two unknowns, two equations, two unknowns, two different systems of equations. Well, the very first problem we did of this lesson was solving systems of equations. So I'm going to pull up my screen share just so I can do my calculator. Calculator on, and let's solve these system of equations. My first one, go to edit. These are both going to be 2 by 3s. So my first one I had was 1a minus a negative 2 and 5. And then I get 4, negative 2, negative 10. All right. Then I go second quit, second matrix, go over to math, double REF, second matrix, enter, enter. And I see there's my diagonal ones. I get negative 5, negative 5. Well, the first number, the top one, is my a, so I know a is negative 5. The next number is my c. Well, c is also negative 5. I'm going to repeat that again with the other one. So second matrix, go over to edit. Still a 2 by 3, but I'm going to put these values in there. So 1, negative 2, 8, 4, negative 2, negative 16. Second quit, just go up to double REF, so I typed it in, hit enter, and look what I get. Now B is the first one, negative 8. D is the second one, also negative 8. So let's think about this. Second go, I let C be. I need to make sure I keep them in the right order. So stop my share so you can see the video on the screen. Right. Second go, I let C be A, B, C, D in that order. A, B, C, D. Okay. So I'm going to say C is, well, I said A was negative 5, C was negative 5. 5, negative 5. B was negative 8, B was negative 8. Negative 8. Let's see how well I did. And there we go. That's our answer. So we're going to do our those. So try 22 and 23 and see if you get those. Okay. And that was the 7.2.